Before the beginning, there was no before. No ticking clock. No distance to measure. No darkness even, because darkness needs space to exist. Then, without warning and without cause we yet understand, everything began. Not as an explosion into space, but as the birth of space itself. An infinitesimally small point held all energy, all potential, all the future galaxies, stars, planets, and you. It was unimaginably hot and dense, not matter yet, not atoms, not even particles as we know them, just pure energy compressed beyond comprehension. And in less than a fraction of a second, it expanded. This moment is what we call the Big Bang. Space itself stretched outward at a speed so extreme that even light could not keep up. This brief, violent swelling, known as cosmic inflation, took the universe from something smaller than a subatomic particle to something vast in an instant. Not expanding into anything. Expanding everything. At first, there were no atoms. No protons. No neutrons. Only a seething ocean of energy so hot that nothing stable could exist. But as the universe expanded, it cooled. And as it cooled, the first building blocks of matter began to form. Within the first second, tiny particles called quarks bound together, forming protons and neutrons, the cores of future atoms. The universe was still blindingly bright, a dense fog of particles colliding constantly. 3 minutes after the beginning, something remarkable happened. The temperature dropped just enough for protons and neutrons to cling to each other. The first atomic nuclei were forged, mostly hydrogen, some helium, and a trace of lithium. This period is known as Big Bang nucleosynthesis. But the universe was still too hot for full atoms to exist. Electrons roamed freely. Light could not travel far without being scattered. The cosmos was an opaque, glowing fog. Then came patience. For 380,000 years, the universe expanded and cooled in silence. Finally, it reached about 3,000 Kelvin, cool enough for electrons to settle into orbit around nuclei. Complete atoms formed for the first time. Hydrogen and helium became whole. And suddenly, light was free. The fog cleared. Photons streamed across space unimpeded. That ancient light still surrounds us today as the cosmic microwave background, a faint whisper from when the universe first became transparent. But though light could now travel, there were no stars to shine. The universe entered what we call the Dark Ages. There were no galaxies, no suns, no planets. Only vast oceans of invisible hydrogen and helium drifting through expanding space. Yet gravity was awake. Very slowly, over tens of millions of years, gravity pulled slightly denser regions of gas inward. Where matter gathered, it pulled in more matter. Clouds grew heavier, tighter, hotter. Around 100 million years after the beginning, in the densest knots of these primordial clouds, pressure and heat rose to extraordinary levels. And then, for the first time since the universe became transparent, new light was born. The first stars ignited. These were not gentle stars like our sun. They were giants, massive, brilliant, and short-lived. Astronomers call them population 3 stars. They were made almost entirely of hydrogen and helium, the simplest elements. Without heavier elements to help them cool, they grew enormous. Hundreds of times the mass of our sun. Perhaps even more. They burned fiercely. And briefly. A star lives by balancing 2 forces, the inward pull of gravity and the outward push of nuclear fusion in its core. But these giants consumed their fuel at a furious rate. In only a few million years, a blink in cosmic time, their fuel was exhausted. And when the outward pressure stopped, gravity won. The core collapsed inward with unstoppable force. Matter crushed upon itself beyond all known limits. The outer layers exploded outward in colossal blasts, hypernovae, scattering newly forged elements into space. At the center, something new was born. A region where gravity became so strong that not even light could escape. The first black holes. Some were born from the deaths of these massive stars, stellar mass black holes, perhaps 10 to 100 times the mass of our Sun. Others may have formed in an even more dramatic way. Some enormous clouds of primordial gas might have collapsed directly under their own weight, skipping the star phase entirely. These direct collapse black holes would have been massive from birth, tens of thousands of solar masses, seeds for the giants to come. And so, roughly 100 to 250 million years after the universe began, the first dark abysses appeared. From pure energy, to particles, to atoms, to stars, to collapse. The first black hole was not the end of something. It was the beginning of a new chapter, one that would shape galaxies, bend space, and anchor the cosmic structures we see today. From nothingness, the universe had already learned how to make light. And now, it had learned how to make darkness.